Hi everyone, we have been learning about covalent bonds for the last 2 days, and today we're going to focus on how to write a molecule which is formed by covalent bonds. How are we going to write the formula, and how are we going to call it? So we're going to go through the naming and formula part. So first of all, let's review what we have learned about ionic compounds. Here are three typical pictures of an ionic compound. If you remember, ionic compound is formed through metal and nonmetal. The metal gave away electron, the nonmetal received the electrons, and we call it electron transfer. And the whole process formed positive and negative ions. Well, they form positive and negative ions. The positive ion have an attraction between this positive ion to all the neighbor negative ions. So we call this a lattice crystal structure. As you can see, this is sodium chloride. This is calcium oxide. This is magnesium iodide. Um, so they are like positive and negative are next to each other and surrounded by each other. Okay, when we write the formula, we use the crisscross method to balance out the charge, means the total positive need to equal to the total negative. Okay, that's for ionic compounds. So covalent bonds molecules are different from ionic compounds. Covalent bonds is formed between nonmetal and nonmetal elements through electron sharing. And instead of forming a lattice structure, or instead of the positive and negative, they stay next to each other. And this covalent molecule is normally an individual molecule. Like each one of the molecules are separated from each other. Most of them are gases or liquid. So for example, this molecule has one carbon and one oxygen and connected, and they have no attraction between this one and the other molecule. And again, this one has no attraction. They normally spread out, stay away from each other. So they are individual molecules. When we write the formula, what we need to do is we need to count the number of atoms. And when we write it, we're just going to write, like, this is one carbon, one oxygen. So we're going to write a C and a O. And the second one is one carbon, two oxygens. So we're going to write CO2. And the last one, there's two nitrogen and four oxygens in the molecule. We just write N2O4. Okay, that's how we write the formula. It's way easier compared to the crisscross method, right? You just count the numbers and write it down. Okay, so couple more things about the formula. And the formula is telling you the number of elements in the molecule, how many of each, right? And it cannot be reduced based on the ratio. For example, these two are different. Carbon 3, hydrogen 6, this molecule contains 3 carbon, 6 hydrogen. You cannot reduce it based on the ratio. You cannot say it's the same as CH4. It's different because this is a type of molecule, this is another type of molecule. And here's the typical structure of glucose. It has 1, 2, 3, 4, 5, 6 carbon in there, and 6 oxygen, the red color one, and 12 hydrogen. When we write glucose, it's C6H12O6. You cannot reduce it to like C and H2O1. You can't reduce it because that's how the molecule look like. Okay, this is the one more difference between ionic compounds with the covalent compounds. Remember, in the ionic compounds, we look at the ratio, right? And in here, you just count the numbers. Okay, that's for the formula part. And then we're going to talk about how are we going to call it. We're going to talk about the naming part, okay? So when two nonmetals combine, they can do it in more than one way. For example, carbon and oxygen. It can be one carbon, one oxygen, or one carbon, two oxygens. And the carbon with hydrogen can form many, many, many different kind of chemicals, like protein, sugar, and fat. those are mainly carbon, hydrogen, oxygen molecules. Okay, they can form all different kinds. So you cannot just name them the same. You can't say this is carbon oxide, and that doesn't work. Okay, what we do is when we name it, we have to use prefix in the naming to indicate the number of atoms in the molecule. Okay, for the other rule, it's similar as what we learned from the ionic compounds. For any binary molecule means for a molecule it contains two different atoms. We normally we just name the first element, use exactly the same name as the one in the periodic table, and for the second element we change the word to the root word, the first part of the word, and change the last part to IDE. And the prefixes, I would say, I'm not going to require you to remember those, but please get familiar with it. Maybe repeat those for a few times. I'm pretty sure you have used this before. So one is mono, two is di, three is tri, and tetra, penta, hexa, hepta, octa, nona, deca. Probably you learned this in math too. Okay, just get familiar with them. And let's go through a few examples. Okay, for example, this one is N2O3. What you do first is find the element name. So for N, we know it's nitrogen. You just write nitrogen. For O, it's oxygen, and we change the last part to IDE, so it's oxide. And then you're going to add those numbers. This is di, so you're going to call it dinitrogen. And this is three, is trioxide. So this molecule is called dinitrogen trioxide. Whenever you see a molecule, a formula, you should be able to write the name. When you see a name, you should be able to write the formula. Okay, we should be able to do both ways. Okay, let's look at a couple more example. For this one, it's a PCl3, and this P is phosphorus. You can find it in the periodic table. Cl is chlorine, and we change the last part to IDE. And then we add the prefix. When there's one for the first element, we don't see mono. Okay, so we just keep it simple. Phosphorus means there's one. And then there's three chlorine, it's a trichloride. Okay, so this SO3 is sulfur trioxide. This is CBr4, which is carbon. 4 is tetra, and the Br is bromine. We change it bromide. Okay, it always takes practice. A couple more trivia things is, first of all, the vowel at the end of the prefix, it will be dropped if there are two vowels together. For example, when we have mono and oxide, there are two O's. We just get rid of one O, become to monoxide, because otherwise it's hard to pronounce. And when there's an A, like tetra, penta, and hecta. When there's a also when there's a A with oxide, A and O, we just drop the A too. Okay, and if the first element is a single atom, then you do not say mono. Okay, that's everything you need to know about formula and naming. We are going to practice during the live class, and please make sure to watch the episode video for a lot more detail about how to name it. Thank you, and I'll see you during live class.